In this video, you'll learn how to use React Express, MySQL, and Node.js to build a complete student information system. From creating your project folders to releasing your application to production, the course will teach you to construct a powerful backend using Express, manage your data with MySQL, and design a responsive, user-friendly frontend with React. By the conclusion of this guide, you'll have a fully operational system for managing students, complete with the ability to add, read, modify, and delete records. Let's start. Begin by creating your project folder, which we'll refer to as sample project for this tutorial. Inside this folder, create two subfolders, client for the front end and server for the back end. Open the sample project folder in Visual Studio Code to start working on your application. Within VS Code, open a new terminal and navigate to the server folder using the cd server command. This ensures that you're working within the correct directory for your backend code. To initialize your Node.js project, run the command npm init. This command initializes a new Node.js project with default settings, creating the package JSON file without requiring manual input. The package JSON file will contain essential information about your project. Open this file and add the following configurations under the scripts section, which defines how your application will start and run.
Start Node server.js. This script instructs Node.js to execute the server.js file when you use the npm start command. It is typically used for production environments. Dev nodeman server.js. The dev script uses nodeman, which automatically restarts the server whenever you change your code. This is especially helpful during development to speed up the testing process. Next, change the name of the main file from index.js to server.js and create the server.js's file. This step provides clarity and consistency in naming your backend entry point. We then proceed to install the following backend dependencies: MySQL for database interactions, Express for building the web server, Cause for handling web security, and Nodemon for automatic server restarts during development. Now, in the process of configuring the server.js file, several essential steps are taken. First, we begin by importing the necessary dependencies that have been previously installed. Once the dependencies are in place, the second step involves creating an instance of the Express application, which serves as the backbone of our server. Following this, we set up middleware functions to serve static files, a crucial aspect of handling client-side assets like CSS and JavaScript. Additionally, we address security concerns by implementing cross-origin resource sharing, QoRS, to manage and control web security. The fifth step involves parsing JSON data from incoming HTTP requests, which is essential for processing data sent from the client. Subsequently, we configure the application's port, often set to a standard like port 5000, to specify where the server will listen for incoming requests. To complete the setup, we establish a connection to the MySQL database, ensuring that our server can interact with the database effectively. Finally, we start the server using app.listen, making it ready to respond to incoming requests and serve as the backbone for our Fullstack application. Next, in the terminal, we run npm run dev. That starts the development server. This command launches your backend server and makes it accessible for testing during development. Try to test your server by going to localhost on port 5000. The next step involves configuring your database. We are going to use XAMPP for local development. Open the XAMPP control panel and start the MySQL and Apache modules. Click the admin button to access the phpMyAdmin page. On the page, create your database. In this tutorial, we will set students as the name of our database. Within the database, create a table called Student Details that will hold details about each student. This step sets up the database, where your application stores and retrieves data. Next, we proceed to the client folder. Open a new terminal and navigate to the client directory using the cd client command. If you haven't initialized a React application, You can create one in the current directory using the npx create react app command. I already did because it takes quite some time. Configure the proxy settings in the package JSON file within the client directory by putting the base URL to your backend. This configuration allows you to use relative paths when making API calls from the front end to the backend, simplifying your API endpoint URLs, and at the same time, making it easier to change the URL for your backend when moving to production. Next, install your front-end dependencies to enhance your development experience. Begin by installing Axios to facilitate HTTP request handling, React Router DOM for client-side routing, and Bootstrap to leverage pre-made styles and UI components. These packages collectively contribute to a smoother and more efficient front-end development process. Then, start the React development server by running npm start. This command launches your React application, making it accessible for front-end development. We then begin to develop our application by customizing the app.js file. Remove its default contents and create a new functional component that will be the foundation for your front end. Import browser router, routes, and route from React Router DOM to facilitate navigation within your React application. Additionally, import Bootstrap for styling purposes. Create separate component files, home, read, edit, and create, to handle creating, reading, editing, and deleting student details. Import these components into the app component and define their routes. Routes for read and edit components can include an id parameter to identify specific students for reading or updating their data. Next, we customize the create component to facilitate the registration of new students into our system. We use Bootstrap classes for styling to create an appealing user interface. Render a form for this purpose. We then implement state management for form values, name, email, age, and gender using the useState hook. Initialize these values as empty strings. Attach on-change events to input elements, allowing the values to update whenever users change the input fields. This ensures data binding between the form and state. Set up an onSubmit function for the form to handle the form submission. Use event.preventDefault to prevent the default form submission behavior, which would cause the page to refresh. Utilize Axios to make a post request to the backend, specifying the API endpoint URL and the data to be sent. This sends the student information to the server for storage. In the server.js file, create the add user post endpoint to handle data insertion into the student details table in the database. Define the SQL query to insert data into the table and bind the user-supplied data to the query. Execute the query and return the result to confirm successful insertion. In the create component, import link and use navigate from React Router DOM to handle navigation within your application. After successfully adding a student, we redirect users to the home page for a seamless experience. We also create a link that allows users to navigate back to the home page for further interaction with the application. Oh, this should be at the top. Test the student creation functionality to ensure that new student records can be added successfully to the database. As seen, the application is working, and after successful insertion, we are being redirected to the home page. This is the complete code for this component.
In the home component, we implement the functionality to fetch registered students using the useEffect and useState hooks. Define a state of an empty array called data to store the fetched data. Inside the useEffect, we make a GET request to the server using Axios to fetch data. We then update the data state variable with the results from the server using the setData method. Lastly, we include an empty dependency array to ensure data is fetched only once when the component mounts. We create an API route in the backend to retrieve registered student data from the database. define a get route for students to fetch and return the data of registered students. To display the fetched student data in the home component, we will use the map function to generate table rows inside a table. First, we will create a table and add a table heading with fields of records to display. Inside the T-body, we implement the map method that maps each student's data into a table row. We also add action buttons to allow users to read, edit, and delete records, include a title and a link to create new student records for a comprehensive user experience. Remember to attach the record's unique identifier, ID, in the action links so that you can identify and perform actions on specific student records. Test the application to ensure that you can create, fetch, and display data from the database in the home component. Verify that the action buttons function as expected. Next, it is time to configure the read component to fetch and display data based on the supplied student ID. This component allows users to view the details of a specific student. To set up the read component, you can copy and modify code from the home component to fetch data based on the provided ID parameter and not data for all students. We supply the student ID to the Axios URL and include it in the dependency array to ensure data updates when the ID changes. To grab the ID from the URL parameters, we use the useParams method. Remember to import it at the top of the page. Let's now modify the Backend API to handle the request for retrieving student data based on the ID. We use a where clause in the SQL query to filter data and retrieve the specific student details. We use the rec.params.id to grab the ID. To enhance the read component's user interface, we will use a list group to display the current student's details in an organized and readable format. Test the read component with different student IDs to confirm that it displays the correct student's information as intended. It is time for us to configure the edit component, which allows users to edit existing student data. Editing involves fetching the previously stored data for the selected student and updating it. To set up the edit component, you can copy code from the read component and paste it into the edit component. Replace read with edit in the code. Transfer the form from the create component, including the submit handler function, to the edit component. This form will be used for updating student data. The difference between this form and the creating form is that this will have already pre-populated values from the backend fetched the same way we perform the reading action. Modify the setData method in the edit component to accommodate the data of the student you're editing, which is typically at index 0 in the array. Also, update the route to the backend to edit user. Adjust the backend API to handle requests for updating student data. This involves creating an SQL query to update the data in the database. Now set the input field values in the edit component to those initially stored in the database. This ensures that users can see and edit existing data seamlessly. Also, update the onChange event method to suit our needs. Test the editing functionality to verify that you can update student records using the edit component. As seen, you are more than reasonable to proceed. Next, we implement the functionality for deleting student records. Create a delete handler function that interacts with the backend API to delete records. To ensure that the application automatically updates after a successful deletion, use a state variable called deleted to track whether a deletion has occurred. Initialize deleted as true to trigger the initial fetch. After successfully fetching data, set deleted to false to indicate no deletion has occurred. Include deleted in the dependency array of the useEffect to trigger data refetching when the deleted value changes to true. In the backend, create an API route for deleting student records. Define the necessary SQL query and execute it to delete the specified record from the database. So your application is more than complete. Test the entire application's functionality, including creating, editing, reading, and deleting student records, to ensure it works seamlessly and as expected. Once your application is complete and thoroughly tested, it's time to prepare it for production deployment for everyone to use. Begin by signing in to your hosting account to host your application. Create a new database and a user with appropriate privileges to ensure your application can access the database. Create a new Node.js application on your hosting platform, ensuring the Node.js version is correctly selected to match your application's requirements. You can verify your Node.js version using the node-v command. Access your application in your browser to confirm that it's working correctly on the hosting platform. Please note the application's URL, as you'll need it to update the proxy settings in your application. Create the student details table within your database management tool in the database hosted on your hosting platform. Ensure that the table structure matches your application's requirements. Update the proxy link in your front-end application with the URL of your live application. This ensures that your front-end can communicate with the back-end on the hosting platform. Modify the database connection details in your application to point to the database hosted on your platform. Now it is time to build your application. Run the npm run build command to build your application for production. This command optimizes your code and assets for deployment. Copy the contents of the build folder generated by the build process and place them into the public directory of your server folder. This step ensures that your Express server serves the production-ready front-end. To package your application for deployment, zip the contents of the server folder, excluding the Node modules folder, to reduce the size of the deployment package. Upload the zip file containing your application to the root directory of your application in your hosting platform and extract it. This step deploys your application to the hosting environment. On your hosting platform, stop the application if it's currently running, and then run the npm install command to install any dependencies needed for production. Start the application on your hosting platform and access it in your browser to confirm it's running correctly in a production environment. Congratulations! You've completed the journey of creating a full-stack student management system using React, Express, MySQL, and Node.js. You can access the complete source code of this project on my GitHub repository, which is linked in the video description below. Feel free to explore the code, fork the repository, and use it as a reference for your own projects. We hope this tutorial has provided you with valuable insights and hands-on experience in developing a real-world web application. Remember that this is just the beginning of your full-stack development journey. You can further enhance your application, add new features, and continue learning to become a proficient full-stack developer. If you found this tutorial helpful and want to stay updated on more exciting web development, tutorials, and tips, please consider subscribing to our channel. Thank you for joining us in this tutorial, and we wish you the best of luck with your future full-stack development projects.